The point -4, 3 is a terminal point of angle theta in standard position. So this is very similar to that little quiz that we did yesterday on question 9. To the nearest tenth of a radian, determine possible values of theta in the domain from -2 pi to 2 pi. In fact, this question is completely identical to question 9 that we had our quiz on. The only difference is instead of saying from -360 degrees to 360 degrees, we now have -2 pi to 2 pi. So the question is the same, it just wants our answers in radians. But because our answers are in radians and it's something that we're not as familiar with, it makes this a little bit harder. So we start the same way that we did before. -4, 3. Where is that point? Well, that would be going 4 to the left, 3 up. There's -4, 3. You could draw a triangle with that. Again, we have to draw our triangle back to the origin because this would be our angle in standard position. This would be our reference angle. What do we know about this triangle? We know this length is 4. We know this length is 3. A squared plus b squared equals c squared. This length is 5. Now taking this triangle and looking at it, well, what could we say? We could say that tan of our reference angle is opposite over adjacent. And whenever you're dealing with your reference angle, you're dealing with an actual triangle, always use positive values. So don't worry about the fact that the 4 is negative to the left. Think of them as actual distances because your reference angle is always a positive angle between 0 and 90. And if you deal with it as a regular triangle and solve this by going to your calculator, and our calculator is already in radians from the previous example, we do this the same way that we did in degrees. What would you do? You would do tan inverse of 3 over 4, and that would get you your reference angle. But now our reference angle, when we push enter, it doesn't show up as an angle that we're used to. We're used to something between 0 and 90 degrees, and we felt comfortable with that. Now we're going to get a number between 0 and 1.57, because that's what 90 degrees is in radians. And so our reference angle is 0.644 to the nearest. I'll just keep all the decimal places for now. And then in the end, it says find all of your angles to the nearest tenth of a radian between -2 pi and 2 pi. Can you see that -2 pi to 2 pi will have some negative angles and some positive angles? If you put 0 in between there, that means our positive angles are going from 0 to 2 pi. That will be this green angle that I have listed there, because all the way around the circle is 2 pi, and starting at 0 and going once around the circle, we only hit that terminal arm once. So what will that angle be? Well, if this was in degrees, you would have said, well, I know up to here is 180, so I could do 180 minus my reference angle, and I would get the right answer. Now we have to do that same process, but in radians. So what am I going to say instead of 180? How far is it to this negative x-axis? It's going to be pi. So I'm going to take pi and minus my reference angle. So go to my calculator, type in pi minus my reference angle, which is right there. Push enter, and to the nearest tenth would be 2.5. So that green angle is 2.5 radians. But going from -2 pi to 2 pi, we also have negative angles. Can you see you have negative angles from 0 to -2 pi? That's once around in the negative direction. If I draw that with a red angle, I hit my terminal arm when I get there. I always like to think in positive numbers, even when I'm figuring out my negative angles. I know from here to here, that's pi as far as an angle. So if I went pi plus my reference angle, that would be the angle of that red arrow. So I go back to my calculator, second pi plus. Now, I have a calculator which allows me to go up to my number like that. Some of you might not have that ability because you have an older calculator. If you had an older calculator, what you can do is when you have calculated this reference angle for the first time, you can, above your on button is a store button. And if you store it as x, that allows you to keep that value in x for as long as you want, until you store something else in x. It won't affect your graphing. You don't have to delete it. It just temporarily stores it as x. So instead of me going up and clicking my value, I can go pi plus x, and it gives me that same answer at 3.8. Now I just use positive values. As a negative angle, then this would be negative 3.8. And we've solved part A. Now for part B, they tell us that cotangent of theta is negative 2. To the nearest tenth of a radian, determine the values of theta from negative 2 pi to 2 pi. Well, if cotangent of theta is equal to negative 2, then tan of theta is equal to negative 1/2. So notice here, the angle theta doesn't change, but the answer, the ratio, is the reciprocal, because cotangent and tangent are reciprocal functions. Now, going to our cast rule. What do we know about tan? We know that tan is negative. What quadrants does that happen in? Quadrants 2 and 4. So until you are really, really, really comfortable with this, I highly recommend you draw out your pictures. If it's in quadrant 2, draw a picture of your terminal arm in quadrant 2. Make your triangle. Label your reference angle. And what do we know about tan? Tan is the opposite over the adjacent. So we would know that the length of this side is 1. The length of this side is 2. And again, I didn't include negatives there because I'm actually thinking about lengths of a triangle. Same thing, you're going to have a triangle in quadrant 4. Terminal arm, always starting from the origin. Draw your triangle. It's going to be the exact same triangle. This side is 1, this side is 2. Obviously, my triangles aren't drawn to scale. It looks like my length of 1 is longer than my length of 2. But we're just getting the general idea. So if you have that triangle, can you see that you can calculate your reference angle? Your reference angle, well, we know that tan of our reference angle is 1 over 2. Notice that even though there was a negative here, when I'm calculating my reference angle, I only use positive values because I'm actually thinking about that triangle and its actual lengths and the actual measure of that angle. Going to your calculator, we can calculate our reference angle then. Tan inverse of 1 divided by 2, 0.464. Now, going back to our domain, where did we want to find our actual angle? We want to find our actual angle between negative 2 pi and 2 pi. So we want to go once around the circle. It'll have positive angles, so that'll be 0 to 2 pi will be our positive angles. We'll also have negative angles, so I'll think from 0 to negative 2 pi. So you see how I always break it up, sort of thinking about my positive angles and my negative angles? Because when we measure those in standard position, we always start at 0, and positive goes counterclockwise, and negative goes clockwise. So starting with our positive angles, we'll do those ones in green. We've got two triangles with two reference angles. Can you see that our first positive angle is this one right here? And again, if we were thinking in degrees and we knew our reference angle, we would do 180 minus our reference angle. But now we're thinking in radians, and instead of 180, we have to use pi radians. So we'll go to our calculator, and this time on my calculator, just so that it's the same for everybody's, I'm going to store my reference angle as x. So above your on button is your store button. Store it as x, so I can just go pi minus my reference angle, pi minus x, and I find out that that first angle is 2.7. But going in the positive direction, we'll also hit the terminal arm in quadrant 4. Now again, if this was in degrees, you would have done 360 degrees minus your reference angle to find that green angle. This time, instead of 360, we're going to use 2 pi radians. Again, we go to our calculator. 2 pi minus my reference angle, and this is where it's nice to have it stored, because I can just go 2 pi minus x, 5.8. Those will be my two positive angles. In the negative direction, so I'll switch colors to red. Again, starting in standard position, so it's starting at the positive x-axis. If I go in the negative direction, I'm going to hit one right here. What's the size of that angle? Well, that's the same as my reference angle. So my reference angle is 0.464 to the nearest tenth. I would write that as negative 0.5. And for my angle in quadrant 2, starting from the positive x-axis, going in the negative direction, if I was dealing in degrees, can you see that you've gone 180 plus your reference angle? So now dealing in radians, I'll go to my calculator. Instead of 180, take pi plus my reference angle, which I still have stored as x. Push enter, 3.6. Of course, that's a negative angle. So I'll write it as negative 3.6 radians. So we've got 4 answers here between negative 2 pi and 2 pi. And when you look at those answers, because you're not used to radians, right now, those angles probably mean nothing to you. You can't visualize them very easily. That's going to take some time. It's going to take some time to think of 2.7 as that angle in quadrant 2. And 5.8 is that angle in quadrant 4. And negative 0.5 is that angle in quadrant 4 in the negative direction. And negative 3.6 as that angle in the negative direction in quadrant 2. One of the ways that can help you sort of visualize these a little bit better, I mean, we have 0, pi, all the way around 2 pi. This would be half of pi, and this will be 3 pi over 2. One thing that's going to help you start to visualize these things is say, well, what is pi as a number? That's roughly 3.14. So if someone says, I'm going skiing, and I'm going to go do a bunch of 3.14s, well, that's like doing a 180. I don't know, 180s aren't very good in skiing because you land backwards, right? 180s in snowboards aren't so bad, but skiing, I think that might be a problem, right? Or no one ever says, I'm going to go do a bunch of 2 pi's, but those would be like 360s. But they talk about it in degrees. But as far as numbers go, if pi is 3.14, 2 pi is 6.28. So if you have an angle of 5, you know that that's less than all the way around the circle, because all the way around the circle would be 6.28. Half of 3.4 is about 1.57, so that's what 90 degrees is like. And 3 pi over 2, if you add 1.57 to this, you're going to get 4.4 71-ish. Again, these are all rounded values because you know pi goes on forever. But those numbers can give you a little bit of a sense of how big an angle is. So if someone says, I have an angle of 2 radians, now it's easier to see that that's in quadrant 2 because it's bigger than 1.57 but less than 3.14. Okay, the questions you can do after this, 8 and 9 deal with your arc length formula. And for these ones, questions like these ones are 13 and 14.